All right, we're looking at verifying inverses today. And so what that does is it's looking at a graph or an equation to see if they are in fact inverses of one another. And so a couple things that we're going to look for is that they're going to reflect one another graphically across the line y equals x. So looking at the points, they reflect. And also, if it crosses this line y equals x, they're going to cross one another on that line y equals x as well. So looking at that, if it's kind of hard to visualize and verify, what you can do is do a couple of points on a table to just kind of check yourself. So x and y, say on this one here, we've got -1, 1, and then 0, 5. And seeing that they cross there for sure, we can kind of say, okay, if they are the inverse on a couple points, then we should be good. So 1, -1, and 5, 0. And again, that's just going off of these 4 points. I can be sure that just like when we were graphing the other day, these are flipped. Um, so if they're inverses, the reflections and they can intersect on the line y equals x. So they'll reflect across this and intersect on the line. Doesn't mean that they have to intersect on that. It just means that they could. You could have ones that, um, if you have a line way out here, that might intersect at some point. They could still be a reflection, but not intersect down here. Or they could be parallel to each other, or possibly even if you have a line that runs perpendicular to y equals x, then you could get ones that it's a reflection, but is actually just the same line, finding the inverse of it. And so looking at the two uh, functions that we have here, we're going to graph these to see if they are inverses. So 1/3 x plus 2, that means my y-intercept would be a 2. And then a slope of 1/3, go up 1 to the right, 3. Do that a couple times. Down 1 to the left. And draw my line there. And we'll go ahead and use a ruler. I'll try to have rulers out for you just to get these lined up as well as possible. So there's my first line. And then we've got y-intercept of -2 and a slope of 3x, so we'll go up 3 over 1. And so we're going to try and see if graphically we can look and tell, are these inverses? Okay, so it's looking good for us, but one of the things I'm going to also do is put this line for y equals x. And when I do that, Looks like it's crossing a little bit off of the line, and this one should be cheated up a little bit more. I can also check points um, and see what I've got. So I've got the point. Just looking at a couple of points here. We got -1, 2, 3, 4, 5, -6, 0. And I also have 0, 2. And over here, I've got, let's see, I've got 0, -2. And I don't really have a point there. I've got the point 1, 1, which means I should have a point 1, 1 here, but I don't. So I'm already like looking for points that would be the reverse. Those are already not matching up. They don't intersect on the line. And if we're drawing it accurately enough, if we see this one has a point of 1, 1, then this one doesn't, that's really enough to tell us, okay, that's not going to be inverses. But doing our tables here is just a little double check to kind of help us. So those would be not inverse functions of one another. They look close, but not quite there. Okay, and on the back, we're going to look at how we take and determine if these are inverses algebraically. So the way that we do that is basically we're going to take and plug in this whole function for x, just like when we swapped the x and the y the other day to get the inverse. We're going to take and put g of x inside for x of f of x. So it'd be f of g of x, basically meaning that we're going to take the g of x function and plug it in for that. So the f of 1/2 x minus 2. So we're taking and putting in 1/2 x minus 2 in for the x value here. So it's this function going in for that x. So that would be 2 times 1/2 x minus 2. And then we still got the plus 4 at the end. I'll distribute that 2 out. 2 times 1/2 just gives me 1, so that would be x. 2 times -2 gives me a -4. And then a positive 4. And so that is going to equal x. Okay, and so when this happens, if it equals x, that means yes, so far it's looking good, it should be an inverse. What we have to do is we have to check the other one. So now we're taking and doing g of f of x, which means I'm going to put in this function, so g of 2x plus 4. So I'm going to take this and put it in here. So I'm taking the function here, plugging it in for the x there. So that would be 1/2 times 2x plus 4 minus 2. And I'll distribute that 1/2 to both of them. Should leave me with an x. 1/2 times 4 is 2. So plus 2 minus 2 also equals x. So when that happens, they both equal x. We're going to say, yes, it is a function. right? So working through it on 4 and 5, we're going to determine both ways. So this will help you in the long run, looking at it both ways, testing it both ways. So we are going to work through, we'll look at it algebraically first, and then we'll look at it graphically as well. Okay. So, and this is one of the things that when we just look at the function 4x plus 3, 1/4 x minus 3, it looks like, well, they swapped that and made that from positive to negative. So it looks like it could be, but we'll test it and see. So again, we're taking this and putting it in for x. So 4 times 1/4 x minus 3. Distribute this. I get 4 times 1/4 gives me x. Oh, and then can't forget the plus 3 there. 4 times negative 3 gives me negative 12 plus 3. And that equals x minus 9. Okay, the good news here, not good news because it's not an inverse, but if I work this one out and I don't get a value of x, I can go ahead and stop there and say, no, that's not a function. It also wants us to graph it though so that we can see it visually, just helping us visualize these inverses so that we can use it a little better on down the road. So graphing these, 4x plus 3, I've got a y-intercept of plus 3 and a slope of 4. So up 1, 2, 3, 4 over 1. Okay, so that'll be our first line. And my second line, I've got negative 3 and then a slope of 1/4. So up 1, 1, 2, 3, 4. And should be able to draw our line there. And then we'll put our line for y equals x. But already kind of seeing that this does not match up. And so even without putting in some of the points to check, can already tell this doesn't cross on the line. So we're still at no, that's not going to be an inverse. So can tell that both graphically and algebraically. And let's look at one more. So I've got, for f of x, I'm going to take this function of g of x and it's going to go in for x. So that's 3 times 1/3 x minus 2. And this is just your algebraic way, again, to check for inverses because if we multiply this function in there, everything should end up canceling out. I'm going to distribute that 3 out. So 3 times 1/3 is x. 3 times negative 2 gives me negative 6 plus 6. So cancel out. So that equals x. We'll make sure we don't run into anything weird on the next one. So we're going to take, again, this function for f of x, plug it into the x over here. So instead of x, we'll put 3x plus 6, and then put the negative 2 there. And 1/3 times 3 gives me just x. 1/3 times 6 gives me a plus 2. And so it brings that down to where those cancel out, and that just equals x once again. So algebraically, we can say, yes, it is. But we'll graph them real quick as well. So that is 1, 2, 3, 4, 5, 6, and a slope of 3. Just get enough points there to draw my line. And then I've got a -2, a slope of 1/3. Draw my line again. And last but not least, to help me determine, I will put my y of x line, dotted line down the middle. And so we notice this does cross there. If I check some points, you got the point 0, -2, and the point -2, 0 for this one. I have -1, 3. I have 3, -1. So kind of thinking about that point by point, it also is matching up for us there too. Any point that we would go to, those are equal and opposite. So again, yes. So you're going to have some where you just work them graphically, some just algebraically, and you got a big chunk where you're doing both to check it. So this is building on itself. Don't skimp on taking your time, checking it algebraically and graphically. It's going to build and help you as we move forward in this.